Hello, Physics Nation. My name is Nate Larmond, and I'd like to do a Khan Academy problem. I think it's called Newton's Second Law, Quiz 2 or something like that. Anyway, a tow truck tows a 1,550 kilo car along a level road. The cable attaching the car to the tow truck makes an angle 37 degrees above the horizontal. The coefficient of friction between the car and the road is mu equals 0.198. And the tension in the cable is 6,510 newtons. Determine the magnitude of the acceleration. All right, sounds crazy complicated, but we're really just going to apply Newton's second law twice. We're going to apply the sum of the forces equals mass multiplied by acceleration in both the x and the y direction. And then we're going to take this tension and we're going to break it up into a horizontal component. Pardon my sloppiness. This is T sub x, what portion of the tension is horizontal, and this is T sub y, what portion of this tension is vertical. Oh, and then the fun equation, of course, friction force equals mu n. So I think those are the important mathematical models. Anyway, let's see. This problem's a little too complicated for me to draw on the screen, so I prepared a solution. Here's my concept sketch. I have the mass, 1,550 kilos. Here's the coefficient of friction, 0.198. The tension is 6,510 newtons, and the direction is 37 degrees above the horizontal. Here's my free body diagram. This is really important because it helps us think about the direction of all four forces. Weight is down, normal is up, friction is negative x, and tension is a mixture of horizontal and vertical. So they want to know the acceleration. That means we need the net force in the horizontal direction. So we start with Newton's second law and we identify the horizontal forces. Well, a portion of the tension is horizontal. All of the friction is horizontal. We traditionally say up is positive and to the right is positive. So I'm going to stick with that frame of reference. The horizontal portion of the tension is positive and friction is backwards. We expand the friction term into the coefficient of friction multiplied by the normal force. And then we expand the horizontal portion of the tension into the hypotenuse, that is all of the tension multiplied by cosine of theta. That will provide us with the horizontal portion. All right, so it doesn't look like adjacent, but the x component is the adjacent leg if this is our angle right here. So the adjacent side equals the hypotenuse multiplied by cosine of theta. And pardon my scrolling, we sort of hit a brick wall right here because we don't know the normal force. So we're going to have to go to the y direction. A vertical force affects the horizontal motion because the normal force affects the friction force. So we're going to take a little detour in the y direction. The sum of the forces in the y direction equals the mass multiplied by the acceleration in the y direction, except there is no acceleration in the y direction. So we're in vertical equilibrium here. The weight is the mass multiplied by the acceleration due to gravity. That's down, that's why it's negative. The normal force is up, and then we have a portion of the tension in the vertical direction. So again, we take this hypotenuse, and now we're looking for this leg, the opposite leg. How do you find the opposite leg? Well, hypotenuse multiplied by sine of theta. And now we're going to solve for the normal force. So we're going to add the weight to both sides, and we're going to subtract the vertical portion of the tension. So the normal force equals the weight minus the vertical portion of the tension. Pardon my sloppiness, the weight is the mass, 1,550 kilos multiplied by 9.8. That's 15,190 newtons. Sine of 37 degrees is 60%, 0.60. So if the tension is 6,510 newtons, 60% of that is 3,918 newtons. And then we simply find the sum of positive 15,000, negative 3,900, and that provides us with the normal force, 11,272 newtons. And then we come back to F equals ma in the horizontal direction because we just found the normal force. Here it is, 11,272 newtons. We're going to multiply that by the coefficient of friction, 0.198. That means the friction force is negative 2,232 newtons. That's opposing the horizontal component of the tension. So there's the hypotenuse, 100% of the tension, 6,510 newtons. Cosine of 37 provides the percentage of the hypotenuse that is horizontal. Looks like about 80%, 0.798. And what is 80% of 6,510? Well, 5,195. We take the horizontal component of the tension and subtract the friction force to find the net horizontal force, 2,963 newtons. We divide by the mass of the system, in this case 1,550 kilos, and that's 1.9 meters per second squared. So let's see if we got this right. 1.9 meters per second squared. And there it is, the happy confetti. Thanks for watching. See you in the next video.